Your phone battery dies before the end of the day. Your laptop barely survives a long flight. Electric cars still take time to charge. And if you want to build something really cool, like a flying car, a giant robot, or even an Iron Man suit, forget it. Because almost every futuristic technology you can imagine has one thing holding it back: batteries. And here's the weird part. Computers have become millions of times faster. AI is getting smarter every day. Robots are becoming more capable every year. So why do batteries still kind of suck? Why are they improving so slowly? Well, it turns out batteries are one of the hardest engineering problems humanity has ever faced, and solving it could completely change our future. Think back to the first iPhone. It came out in 2007. Since then, phones have become thinner, faster, and thousands of times more powerful. Yet your phone still needs charging almost every day. Why? Because batteries haven't improved at the same speed. In fact, battery energy density, which is basically how much energy you can store in a certain amount of space, only improves by a few percent every year. A few percent? Not 50%, not 100%, just a little bit. That might sound disappointing, but there's a reason for it. Making computers better is mostly about making things smaller. Making batteries better means changing chemistry itself. And chemistry doesn't like shortcuts. A battery isn't a little box that stores electricity. That's how most people think of it. But it's actually more like a tiny chemical power plant. Inside every battery are materials that want to react with each other. As those reactions happen, electrons flow. And that's the electricity that powers your devices. The problem is, chemistry has limits. You can't just tell scientists to make a battery that holds 10 times more energy. The atoms themselves decide how much energy can be stored. And we're already surprisingly close to those limits. Which is why every improvement gets harder and harder. It's like trying to squeeze more water into a glass that's almost full. Eventually, there's just nowhere left to put it. And this isn't just about phones. It's about almost everything. Take electric cars. The batteries inside them can weigh hundreds of kilograms, and even then, they still have limited range. Now imagine trying to build an electric plane, or a flying car, or a giant robot. Suddenly, batteries become a massive problem. A battery powerful enough to fly for hours would be incredibly heavy. But making it lighter usually means storing less energy. It's a horrible trade-off. In engineering, weight is everything. Every kilogram matters. This is why some futuristic technologies still don't exist. Not because we don't know how to build them, but because we don't have batteries good enough to power them. In a weird way, the future is waiting for better chemistry. Now you might be thinking, why not just make batteries bigger? Well, imagine putting a 1,000-kilogram battery into a drone. It might have loads of energy, but it would be too heavy to fly. The same thing happens with cars, and robots, and aircraft. Energy density matters more than total energy. Engineers don't just want more battery, they want more energy in less space. That's the real challenge. And unfortunately, that's incredibly difficult. Every battery has enemies: heat, degradation, fire, charging speed, cost, safety. If you improve one thing, you often make something else worse. A battery that charges in 5 minutes might wear out quickly. A battery with huge capacity might become dangerous. A safer battery might become heavier. Everything is a trade-off. And that's why battery engineering is so difficult. There isn't one perfect solution. There are thousands of tiny compromises. But there is some good news. Scientists all over the world are working on new technologies. One of the biggest is something called solid-state batteries. Instead of using liquid materials inside the battery, they use solid ones. In theory, they could store more energy, charge faster, last longer, and be much safer. If they work at scale, they could completely change electric cars, drones, robots, and maybe even electric aircraft. But there's a catch. Building them in a laboratory is one thing. Producing millions of them cheaply is another. And that's where so many battery breakthroughs get stuck. The science works. The manufacturing doesn't. At least, not yet. Now think about what happens if someone finally cracks this problem. Imagine a battery that's twice as good as today's. Suddenly, your phone lasts several days. Electric cars become cheaper and go much further. Delivery drones become normal. Flying taxis become possible. Humanoid robots become far more practical. Even space exploration gets easier. One breakthrough in battery technology could unlock dozens of other industries. That's why companies and governments are spending billions trying to solve this problem. Because whoever builds the next great battery won't just make better phones. They might help build the future. So, why are batteries improving so slowly? Because unlike computers, you can't simply make chemistry smaller. You're fighting the laws of physics, the limits of atoms, and some of the hardest engineering challenges on Earth. But every year, scientists get a little bit closer. And one day, the biggest technological breakthrough of our lifetime might not be a robot, or an AI, or a flying car. It might just be a better battery. Because when batteries improve, everything else does too.